In the cold winter of 1933, during the absolute lowest point of the Great Depression, American factory production was falling apart into complete ruin across the nation. Over half of the machine shops in the country had shut their doors for good. Factory investment money had completely dried up, and skilled toolmakers who had spent a lifetime mastering their craft were standing in long breadlines outside locked factory gates. Industrial plants stood empty, dark, and silent across every major manufacturing city in the United States. Inside the few machine shops that managed to stay open, daily work moved at a painfully slow speed. To make a simple steel stamping mold, the hard metal block needed to shape everything from car fenders to toaster covers. A master machinist had to take a thick slab of solid tool steel and turn expensive raw metal into useless piles of scrap shavings. He had to set up a heavy shaping tool or a milling machine, slowly scraping away metal for hours at a time. He would drill dozens of small holes along a layout line, knock out the middle core with a heavy hammer and chisel, and then spend 2 full days hand filing the rough inner edges flat. This slow work consumed dozens of exhausting hours for a single die piece, at a time when no factory owner had extra cash to pay for slow labor or $10,000 machinery. Factory managers could not afford to waste expensive raw steel or pay workers for unnecessary overtime hours. A 33-year-old machinist from Minneapolis walked into a struggling tool shop, carrying a new invention that changed metalworking forever. Instead of grinding a heavy block of steel into dust over 3 long days, his machine sliced through a 2-inch slab of hard alloy metal in just 20 minutes. It cut out the inner shape in one clean, reusable piece that could be saved for other parts. This new process reduced toolmaking time by 80%, saved 90% of the raw steel, and cost far less than a standard milling tool. In the middle of the deepest economic crash in American history, this machine saved toolmakers from losing their businesses. You are watching Rivet and Rebar, the documentary channel where we share stories about the quiet companies that built our physical world. If you enjoy learning about forgotten industrial history, smart engineering, and creative inventors, take a second to click the like button and subscribe right now so you never miss our upcoming videos. Now, let us travel back to where this remarkable story first began in Winona, Minnesota, in the year 1900. Born in Winona, Minnesota, in 1900, Leighton Alexander Wilkie grew up in a family that lived by tools and machinery. His father was a mechanical contractor and inventor who kept a busy home workshop full of belt-driven equipment. Leighton and his younger brothers, Robert and James, grew up surrounded by the smell of machine oil, iron dust, and steam engines. By his late teenage years, Leighton possessed an instinctive mechanical talent that made him stand out as a master toolmaker among his peers. Around 1922, 22-year-old Leighton teamed up with his brothers to open the Wilkie Machine Company inside a modest shop in Minneapolis. They operated a general repair shop, taking on whatever mechanical work came through the door, fixing car engine cylinders, repairing farm tools, and making custom replacement parts. To create steady income, Leighton invented a portable cylinder grinding tool for auto mechanics called the Wilkie high-speed grinder. The grinder sold very well across regional garages, giving the young brothers their first real taste of factory production and commercial sales. By the late 1920s, the Wilkie shop expanded into contract tool and die work, making precise punch sets for factory press machines across the Midwest. Standing over his workbench in Minneapolis, watching his workers spend 3 full days cutting out a single hollow steel die cavity, Leighton realized a basic flaw in the machine tool industry. He saw that traditional shop methods were wasting vast amounts of valuable metal and expensive human labor. Traditional metalworking tools, like lathes, planers, shapers, and milling mills, all created shapes by destroying raw material. To make a part, they took a large metal block and shaved away material from the outside, turning 90% of expensive steel into useless chips. If a toolmaker needed a 5-inch hollow square inside a 10-inch steel block, he had to grind that 5-inch inner block completely into dust. Woodworkers had solved this exact problem years earlier using the band saw, running a flexible saw blade over 2 spinning wheels to cut curves without wasting the inner wood piece. However, back in 1930, every trained engineer believed that you could never use a band saw on hard steel. A metal saw blade running fast enough to cut tool steel would build up intense friction heat. That heat would dull the metal saw teeth in seconds or snap the thin steel band under heavy pressure. Determined to prove them wrong, Leighton Wilkie believed that controlling 3 main factors, blade speed, pushing pressure, and metal blade quality, would allow a thin saw blade to slice through hard tool steel just as smoothly as soft wood. During 1930, while the American economy was crumbling around him, Wilkie locked himself inside his shop to solve the metal band saw puzzle. He experimented with high-carbon steel blades, creating fine-tooth patterns with special angles that could clear metal chips without jamming. To prevent friction heat from ruining the blade strength, he engineered a variable speed control system. This allowed the machinist to slow down the blade to a slow crawl for hard steel alloys or speed it up for softer metals. Engineers soon noticed the next major problem: cutting hollow shapes inside a solid plate. A band saw can easily cut a curve from the outside edge of a sheet. But how do you cut a hollow cavity inside a solid block of steel without cutting through the outer wall to get the blade inside? To solve this problem with creative mechanical genius, Wilkie built a small electric welder directly onto the side frame of the machine box, right next to a small grinding wheel. For a hollow internal shape, the machinist drilled just one small starter hole through the steel block. He cut the flexible saw band in half with snips, passed one end of the blade through the starter hole, and clamped the 2 blade ends into the built-in electric welder. Pushing a button sent a quick pulse of electric power through the metal ends, welding them together in a flash of sparks. The worker smoothed the weld joint on the small grinder, mounted the loop onto the drive wheels, and began sawing out the inner shape. When the cut was finished, he snipped the blade, pulled it out of the metal part, and welded it back together for the next job. Housed inside a single steel cabinet, this complete machine system could perform continuous shape sawing, continuous filing using interlocked file segments on a belt, and smooth surface polishing. This versatility led Wilkie to name his new machine the DoALL, a tool designed to handle all metal finishing jobs on one compact footprint. After filing for patents on his contour saw and built-in welder in 1933, Wilkie formed Continental Machine Specialties Company to build it. Yet inventing a useful machine during the Great Depression was only half the battle. The real miracle was how Leighton Wilkie managed to sell it to reluctant factory owners across the country. Across America in 1933, factory owners were terrified of spending money on equipment. Banks were closing down, customer orders were rare, and no shop manager had extra funds to buy new machinery. Old machine builders were going bankrupt because their sales teams sat in empty offices waiting for orders that never arrived. Shop superintendents refused to take risks on new technology during such uncertain financial times. Because normal catalogs would not work, Leighton knew he had to demonstrate its cost-saving value right in front of shop managers. With his personal savings on the line, Wilkie bought a fleet of new Ford delivery trucks. He converted the rear cargo space into mobile showrooms, mounting a working DoALL contour saw inside each truck powered by a portable electric generator. He hired a group of active young machinists, trained them as demonstration salesmen, and sent them driving across American industrial towns. A DoALL truck would arrive unannounced at the loading dock of a struggling machine shop in Ohio, Illinois, or Pennsylvania. The salesman would walk inside and ask the shop foreman for his most difficult, slow die-cutting job. The foreman would hand him a solid slab of tough tool steel expecting the salesman to fail. The salesman led the foreman out to the truck, drilled a starter hole, welded the blade in 60 seconds, and cut out the complex inner die shape in 15 minutes while the foreman watched in total surprise. Financially, the sales pitch was impossible to resist. In 1935, a standard milling machine or heavy shaper cost between $5,000 and $10,000, money no small shop possessed. The DoALL Contour saw sold for about $1,000. Even better, it paid for itself in less than 30 days by cutting tool-making labor costs by 80% and saving 90% of expensive steel stock. Small machine shops on the edge of bankruptcy bought DoALL machines because it was the only way they could submit low bids, win contract jobs, and keep their doors open. By 1937, Continental Machine Specialties outgrew its Minneapolis shop and moved into a large, modern factory complex in Des Plaines, Illinois, near Chicago. The DoALL saw had become an essential tool on factory floors across the nation. With the start of World War II, Leighton Wilkie's Depression-era invention became a vital machine tool for Allied production. American factories needed every available machine tool to build military hardware at maximum speed. When the United States entered the war in 1941, American industry faced an urgent production goal. The military needed thousands of bomber planes, fighter jets, tanks, field guns, and naval ships right away. Every single war machine required thousands of stamped metal parts and custom assembly clamps. Every stamped part needed a metal die set to shape it. Old manufacturing methods could not keep up with the overwhelming demand for new defense tooling. Tool-making capacity quickly became the main slowdown for the whole war effort. There were simply not enough master toolmakers or milling machines in the world to build the required tooling using old methods. At major defense plants like Ford's Willow Run Bomber Facility, Douglas Aircraft, and Boeing, rows of DoALL saws were installed to speed up production. Workers used DoALL saws to slice out airplane structural ribs, armor plate shapes, and heavy press dies in hours instead of weeks. Compact and versatile, DoALL machines were selected by the United States Navy as standard equipment for wartime ships. Every major U.S. Navy battleship, aircraft carrier, cruiser, and repair vessel carried DoALL band saws inside their floating machine shops. When a warship suffered battle damage thousands of miles away in the Pacific Ocean, Navy machinists used onboard DoALL saws to cut custom replacement parts directly from steel plates, keeping ships in battle without returning home. Throughout the war years, the Des Plaines plant ran 24 hours a day, shipping thousands of contour saws, band filers, and millions of feet of saw blades around the globe. By 1945, the small shop started by three Minnesota brothers had grown into a global industrial business known as the DoALL Company. As the post-war economic boom took hold, Leighton Wilkie turned his attention to a new personal goal: preserving industrial history and teaching the next generation of American engineers. He wanted young people to appreciate the ingenuity that made modern manufacturing and comfort possible. Deeply concerned that modern society took factory progress for granted, Wilkie worried that people were forgetting the basic mechanical tools that made modern life possible. In the 1950s, he created the Wilkie Brothers Foundation and built a traveling educational exhibit called The Dawn of This Age. Through millions of dollars in investments, he gathered historic machine tools, working models, and original patent devices. He built a massive 10-foot-tall visual wall chart that showed the history of human tools, from simple stone axes to modern automatic turning mills. He constructed the Hall of Progress at the DoALL headquarters in Des Plaines, featuring a working full-scale model of James Watt's 1776 steam engine boring tool to show students how mechanical precision created our modern world. While Leighton focused on technical education, the company kept advancing saw blade technology. In 1953, DoALL launched the world's first high-speed steel saw blade, named the Demon Blade. Before this invention, saw bands were made of flexible carbon steel that softened when run at high speeds. The Demon Blade used tough, high-speed alloy steel, allowing saw bands to cut 10 times faster and last 30 times longer, transforming metal cutting across steel mills and heavy forge plants worldwide. Innovations continued through the 1960s, with carbide-tipped saw blades capable of cutting through tough titanium, nickel alloys, and nuclear-grade stainless steels that destroyed standard cutting tools. These advanced cutting tools allowed factory workers to shape aerospace metals with unprecedented speed. Upon retiring from active management in the 1970s, Leighton Wilkie left behind a business that had grown into precision surface grinders, measurement gauge blocks, cutting fluids, and industrial sales networks spanning over 50 countries. He passed away in 1998 at the age of 98, having lived through nearly a century of industrial growth that his own hands helped shape. Today, the global machine tool industry looks very different than it did when Leighton Wilkie drove his sales trucks through rural roads during the Great Depression. Automated multi-axis CNC milling centers, precision fiber lasers, and wire EDM machines handle fast production inside modern aerospace factories. Visiting almost any prototype job shop, repair facility, auto restoration garage, or university engineering lab in North America today, you will still find a classic olive green or industrial blue DoALL band saw standing near the wall. Many of these sturdy machines were cast in the Des Plaines foundry back in the 1940s or 1950s. They feature heavy iron frames, hand-wheel speed controls, and built-in electric welders that still throw a shower of bright sparks whenever a machinist joins a new saw blade. Sturdy design keeps these tools working in daily service 70 or 80 years after leaving the factory floor. Leighton Wilkie built them with generous iron and simple mechanics that refuse to break. While modern computer machines become useless when their electronic circuit boards are discontinued, a classic DoALL saw needs only a fresh blade loop, a drop of oil, and a machinist who needs to slice a shape out of solid steel. His focus on practical innovation left a lasting mark on manufacturing shops around the globe. Ultimately, Leighton Wilkie's true legacy went far beyond a successful tool business. It changed how human beings shape the physical world. He proved that real engineering talent does not come from building bigger, expensive machines to turn raw metal into scrap, but from finding a simple, smart path that saves both raw material and human labor. By transforming a hard economic crisis that closed thousands of businesses, he showed American industry how to achieve more with less. Long after the financial struggles of the 1930s have faded into history books, his green iron band saws remain inside machine shops, turning solid steel into steady progress one saw tooth at a time. If you enjoyed this deep look into the industrial companies that built our world, make sure to click the subscribe button. Leave a comment below telling us what historic machine builder we should cover next, and click the video on your screen right now to stay inside our archive.